All right, in this video, we are going to talk about side-side angle, second example of side-side angle. And so what we want to do is to solve the triangle that we're given here. We're given that angle A is 30 degrees, side A is 2, and side C is 4. So what we want to do is, we know that this is, I already told you it's side-side angle, but just in case, say you weren't sure what case it was, right, then you would sketch out the triangle with angles A, B, and C, and sides A, B, and C, making sure that side A was opposite angle A, side B was opposite angle B, and side C was opposite angle C. And then label those triangles with what you know. I know that angle A is 30 degrees. I know that side A equals 2. And I know that side C, right, is 4 units, like so. All right, and so then what I want to do is to use the law of sines to find the angles, one of the angles opposite one of the sides that I'm given. I'm going to go with the biggest side over here, 4, and so that is side C. So I'd have sine of angle C over side C is equal to sine of, and for the other one I'll have to use A again because that's the only angle side pair that I know. I know both the angle and the side opposite, right, which is 2. So let's see. So I'm going to use A here. All right, and then I'm going to fill in for what I know. I know that I don't know the angle C. I know that the sine or side C is equal to 4. I know that angle A is 30 degrees, and I know that A is 2. Okay. All right, and so I can solve by cross multiplying, right? So I get 2 sine C is equal to 4 sine 30, right, by multiplying through here and through here. And then I can divide both sides by 2. That gives me sine of C equals, and if I solve this out, actually I'll go ahead and do it the way I would do the other ones. So 2 goes into 2 4 times, so I get 2 sine 30. And so sine of 30 degrees is a half, and a half times 2 is 1. So I get that sine C is 1. But let's just say, maybe you didn't notice that. The next thing that you would do is to take the inverse sine, right, of both sides. And so that would give you that the angle of C equals the inverse sine of 2 times the sine of 30 degrees. If you go to the calculator, and on Desmos, I have to do that as arc sine, and it should be in degree mode, which we are. So you can see you get 89.9999 like that. So unfortunately, it doesn't. It's not exact, but you can see here that if we actually did it this way, if we actually rounded that to 2 decimal places, right, we'd get C is 90 degrees on that. Okay. Here, if we did it exact, which is a little bit better, we would get 2 times a half, right? That's the sine of 30 degrees. because we know that's one of the special angles, and so 2 times a half equals 1. If we did arc sine of 1, right, instead of 2 times sine 30, we would get exactly 90 degrees here, okay? So we get exactly 90 degrees, right? What that means is, if you go back to our law of sines handout, right? We've done step 1. We've solved for the sine of one of the unknown angles, and then we use the inverse sine key, right, to solve to give an approximation of that error. You can see that we got 90 degrees, all right? And so what that means is the triangle is a right triangle, all right? And so that means you'll only get one possible triangle. So we know right now, based on that, because this is 90. In fact, it's not really approximately 90, right? We know if we looked at it exactly, it's exactly 90 degrees, right? So we know that we get one triangle out of this. And we know that it's a right triangle. Okay? And so now we can actually know that angle C is a right triangle. Now we don't even need to use the law of sines for the rest of it, right? I can kind of redraw my triangle, and it's going to look like this. I know that angle C is a right angle. I know that angle A is 30 degrees, right? And that tells me that this angle B, right, would have to be a 60-degree angle. Okay. Then we know C is 4 and A is 2. And so all we're left with is B, right? And so what we can do is just use triangle trig. We know that the sine, or the cosine, of 30 degrees would be, right, adjacent, which would be B over hypotenuse. So B over 4, right? And so then cross multiply, right? We can put that over 1 and cross multiply. We get 4 cosine 30 degrees equals B. And then you can plug that into your calculator, making sure that you're in degree mode. So that would be 4 cosine of 30, right? That's going to give you that B is approximately 3.46 units in this case. Okay. And that's it for this problem. So if you get a 90-degree triangle, then you don't even need to use the law of sines anymore. You can switch back over to triangle trig. I don't know how many Newton problems are like this one, but I just at least wanted to give you one example like that. And in my experience, most of the problems are in the law of sines sections. In most problem sets, there's not too many like this. But anyway, I just wanted to give at least one example of it.